All right. So we got another trigonometry question, but this one is very similar to another one we have seen with the Pythagorean theorem. And that's going to be important because we're going to have to find an angle, but before that, we're going to have to find some sides. The shaded angle is what we have to find. Given the base is a square with sides 40 inches long, and these other edges are 57 inches long. Okay. So when the problem is three-dimensional, then pictures are more difficult, but they're still worth it. Practice this perspective drawing. So this is sort of a rectangle in 3 dimensions, sort of floating like this. And then you look for the center, you go up, and then you connect it with these 4 points there. And then one thing you can do to make the picture better is to darken the sides that should be visible. Like this one shouldn't be visible, right? Unless this pyramid is made of glass. And if you do that, it will kind of pop out from the... Practice this. The base is a square with sides 40, and this point is above the center, and all of these other edges are 57 inches long. And so we have an isosceles triangle here. This face of the pyramid is an isosceles triangle with base 40 and other 2 sides 57, 57. What we're going to first find is this line here. Now, it looks like this is the height of this triangle, but it is not the height of the pyramid. I believe it's called the slant height, is this line here. Actual height is this vertical line. And if you connect, you see that in this triangle here, the slant height is the hypotenuse. So the regular height is actually less than the slant height. You should have some deja vu because we use a Pythagorean theorem to find this line and then another Pythagorean theorem to find this line. Well, we don't have to find a second line. We're going to be able to use, if we find this line and this line, we can use cosine, right? Adjacent over hypotenuse to find that angle. So the first task is to find the height of this isosceles triangle. And because it is isosceles, is the reason why we can easily find it, because we know this is also a symmetry line. So we can call this H, and the Pythagorean theorem stated for this triangle states that h squared plus 20 squared is 57 squared. We solve for H. 20 squared is 400. I don't know about 57 squared. Let's just use the calculator. So let's just use the calculator. Let's just check, maybe this is a square number. So one really quick way to take the square root of a number is to raise it to the power of 1/2. So this is and then the calculator understands that I want to exponentiate the answer, and then just enter 0.5. I think that's the quickest. No, this is not pretty. This is 53 and change, which makes sense. It's slightly less than 57. So that means we can just go with this, with the exact value, which is square root of 2849. Some squares we might be able to drag out some squares from under the radical, but we shouldn't spend much time with it because remember, we have to find the approximate value of an angle. It's not going to matter what form we're going to use. Because now, if we call this angle alpha, well, this side is 20, right? Because, well, from viewing above, we're going to the center from the midpoint of a side. So that is 20, if the whole side is 40. So then we have a right triangle. This side is 20. This side is the hideous square root of 2849. And therefore, and this is a right triangle. Therefore, we can use right triangle trigonometry to find that angle. Cosine alpha would be 20 adjacent over hypotenuse, 20 divided by square root of 2849. And therefore alpha is the inverse cosine 20 over square root of 2849. And we're asked, that's the exact value. It's not very pretty, but we are asked for an approximation, 3 or more decimal places. So we have second cosine, a parenthesis is open for us, 20 divided by, we're going to say square root, which opens a second pair of parentheses. And we enter 2849, close the parenthesis, close the other one, fingers crossed, almost 68 degrees. If you look at the picture, kind of makes sense. So we have 67.9942 degrees. We're asked to have precision three or more decimal places. So we need more. Let's see. 67.99422. And we got it right. Excellent. Thank you for watching.